Today I want to talk about how we can relate the subatomic particles, so that would be electrons, protons, and neutrons, to the periodic table. So I have one box here from the periodic table. This is the box for carbon, so C for carbon, and this chemical symbol, whether it's one letter or two, is always going to be here at the center. And then the number here at the top is called the atomic number, and the atomic number is unique to each element. And the atomic number tells you how many protons are in the nucleus of your atom. And I'm just going to abbreviate that with P there, number of protons. So we know that the nucleus is made up of protons and neutrons. And so this atomic number tells you how many there are. And if you look at the periodic table, then there's a different number for each element. And that's what helps to give them their unique characteristics, is their number of protons. Now the number here at the bottom, this 12.01, at least for carbon, is the atomic mass. And the atomic mass is the mass of one atom in atomic mass units. Atomic mass units. It's abbreviated, at least it used to be AMU. You'll also see it as just U for atomic mass units. We'll also talk about another way that we can use atomic mass later in the quarter when we talk about moles. But for right now, the mass tells you how much matter there is in one atom of our element there. And remember that our model of the atom says that there's a nucleus at the center, and the nucleus is made up of two types of particles. It's made up of protons and neutrons. So I'm kind of showing that with clear and not clear particles there. And then around that, and again, this isn't a perfect model, but just to use Rutherford's model here, we have electrons in clouds around it, or in orbits around it, or in atomic orbitals around it, or however we want to talk about it. Okay, so there's our model of the atom. Now, the subatomic particles, when we're talking about how this relates to the periodic table, the mass tells you how much matter something is made up of. And the mass in an atom is mostly talking about the nucleus. So, which is made up of protons and neutrons. It accounts for the mass of an atom. How much matter it's made up of. We think about mass and weight as sort of interchangeable ideas. So the mass of the atom comes from the nucleus, and how much space it takes up, or the volume, so kind of the radius of the atom, if you think about it as a spherical particle, or how much space it takes up in general, is accounted for by the electrons, or the electron cloud. So electrons are super teeny tiny and don't account for much of the mass of the overall atom, but they do take up a lot of space because they're moving around the nucleus, and so they're moving around, they're taking up a lot of room, and that accounts for most of the volume. So when you talk about things like atomic radius, for instance, then that's talking about the volume of your atom. When you talk about the mass, which is included in our atomic mass number here, then you're talking about the mass of the nucleus, so the mass of the protons and the neutrons together. So there's information we can get from the symbols on the periodic table, and I want to talk briefly about different ways that we can kind of understand matter better using both our knowledge now of our subatomic particles as well as the periodic table. And to do so, we have to talk about isotopes. The prefix iso means the same, and when we're talking about something being the same here, it's the same number of protons. So if we have two isotopes of each other, they're going to have the same number of protons, but a different number of neutrons. Okay, so isotopes have a different number of neutrons, same number of protons. So because they have a same number of protons, they're both the same element. But because they have a different number of neutrons, then they have a different mass. Now, the particles of the nucleus, which are neutrons and protons, are sometimes together called nucleons. So if you count the number of nucleons, then you get what is called the mass number. Mass number. And this gives you the total number of nucleons. Now again, this is related to mass because most of the mass comes from the nucleus. But this is going to give you a whole number count of all of the nucleons in the nucleus. For example, one of the common isotopes of carbon is carbon-12. And you can write the isotope symbols a couple different ways. You can write it like this, where you have the symbol, and then this is a hyphen, not a minus sign. And then this is your mass number. Another way that you can write this is like this, where we have the carbon here, we have 12 at the top, 6 at the bottom. The 6 tells you your atomic number. That was that number on the top in your box in the periodic table. So that's the number of protons that it has. And this would be your mass number. This symbol here, the way that we talk about this here, and kind of this one as well, this is called a nuclide symbol, referring to the nucleus. And it doesn't matter which way you represent the symbols here. I will tend towards this one for this level of chemistry. As you move up in chemistry, they tend to use the nuclide symbol. So I'm just showing you both because you're going to run into both. But let's go back to our C12 here. I'm going to get a fresh piece of paper. So C12. If we go back to our box on the periodic table, our atomic number for carbon is 6. That tells us that there's 6 protons in the nucleus. And that's what we get from the atomic number. This 12 here is your mass number. This is the total number of protons plus neutrons. So if we know that it has 6 protons, and we know that it has 6 protons because it's carbon, right? That's a unique identifying feature, is the number of protons in the nucleus. Then this carbon-12 must have 6 neutrons, right? So I took the mass number, which is the total, subtracted my atomic number, which is the number of protons, and what's left over then is my 6 neutrons. Okay, so from an isotopic information like this, or our nuclide symbol, we can figure out how many nucleons there are, how many particles in the nucleus. Let's look at another example. If I take, let's say tin. Tin is SN, comes from Stanham, which is a town in Wales where it was mined. If I take tin 120, for instance, if you go to your periodic table and look up tin, then you will find that its atomic number, that's that number at the top, is 50. That means that in one atom of tin, there are 50 protons in the nucleus. Okay, so that's what the atomic number tells me. So how many neutrons are in this isotope of tin? Tin 120 is the way that we would read that, just like carbon-12 up here would be the way we'd read this. So in tin 120, how many neutrons do I have? And then our method again is we take the mass number, that's this number here, and subtract from it the atomic number, that's the one that we get from the periodic table, and that will give us the number of neutrons. So if I take in this case my 120 and subtract my 50, then that will give me 70 neutrons. Okay, so in that particular atom of tin, I have 70 neutrons. Now this is really useful for a number of different ways, because if I take a block on the periodic table and I just kind of pick an element here, so let's pick oxygen, for instance. Here's oxygen. Oxygen, its atomic number is 8. Its atomic mass is 16, or 15.999. So if I take my oxygen here, then if I'm given information about the mass number, so if I'm given kind of an isotope symbol like this, so let's say that I have oxygen 16. Okay, then I can figure out, if I know that it's a neutral atom of oxygen, because atoms are neutral and thus we're given information otherwise, then I can figure out all 3 of the different subatomic particles. How many are in this particular isotope of oxygen? So in this particular isotope of oxygen, the number of protons that I have comes from my atomic number. My atomic number is the one at the top there, so I have 8. My number of neutrons comes from taking the difference between this mass number and my atomic number, so I also have 8. My number of electrons comes from the fact that this atom is neutral. When I say that an atom is neutral, I mean that it has no charge. And if it has no charge, then that means that it has the same number of protons as it does electrons, because protons are positively charged, electrons are negatively charged. So if something is neutral, it means that the number of protons has to be equal to the number of the electrons. So that means that in this particular isotope, which is a neutral atom of oxygen, right, there's no information about it being charged or anything, and we'll get into charges on atoms later on, then it has 8 protons, 8 neutrons, and it also has 8 electrons. Okay, let's look at another example. All right. Let's look at magnesium. Okay, magnesium is 12. Okay, I'm just going to give you the atomic number here. You can look up everything else on the periodic table. So if I give you an isotope of magnesium, that's magnesium 26. Okay, so magnesium 26, now there's no charge on this thing, so that means the number of protons has to be equal to the number of electrons. So here's my protons, here's my neutrons, here's my electrons. So just thinking about this here, and we're doing this along with me at home, so the protons here is going to be how many? Think about it to yourself, and then you say, all right, well, I go to the periodic table, the atomic number is 12, so I must have 12 protons in my nucleus. I know that this is a neutral atom because I'm not told that it has a charge on it, so that means that I have to have the same number of protons as electrons, so I must also have 12 of these guys. And now, how do I figure out my neutrons? Okay, well, I'm given this symbol, magnesium 26. So 26 is my mass number. So I must need to take the mass number and subtract from it my number of protons. And that will give me my number of neutrons. So if I take 26 minus 12, then that gives me 14. Okay, so given an isotope symbol or given a nuclide symbol, you will always be able to determine all 3 of the subatomic particles, how many are in that particular atom. And that can be really important information. So I want to summarize here, just kind of at the end. There's 3 important terms, and they all kind of look similar to each other. So there's atomic number, and atomic number is the number of protons. And this is the number that's at the top in your periodic table. There's mass number, and the mass number is the total number of nucleons. So it's the number of protons plus the number of neutrons. And this is not to be confused then with atomic mass, which kind of looks like both of them. And the atomic mass, remember, is the mass of one atom in atomic mass units. So these are three important terms that are often confused with each other because they look very similar to each other. So atomic number, the number at the top in the periodic table, the total number of protons in the nucleus. The mass number is the total number of nucleons and usually gives you information about an isotope. Isotopes have the same number of protons because they're the same element and a different number of neutrons, which means that it changes the mass of it. And then atomic mass is the mass of one atom of that particular element in atomic mass units. And this atomic mass is actually a weighted average of all of the masses of the isotopes for that particular element. But that kind of goes beyond the scope of our course, so I didn't want to mention that, but I just did, so there we go. All right, so if you have questions on this, don't hesitate to ask, and I'll talk to you again soon.